Okay, so as we have learned in the last class, or not in the last class, in applications or in derivatives, that what do we find out? We find out the rate of change, right? So if there are two variables, one independent and one dependent, how the independent variable changes with respect to the dependent variable, right? So that is what we find out in your differentiation. And usually y is your dependent variable and x is your independent variable. That is why we write down dy by dx, right? So that is what we do. So here we have I would say real life based problems, right? So I will solve that and I will share it later on as well, right? Right after the class, I will share it. So let us get started with the first question in applications of derivatives. The first question is find the rate of change of area of the circle with respect to its radius r when r is equal to 3 centimeters and r is equal to 4 centimeters. We have to find out the rate of change of area with respect to r, as in we have to find out dA divided by dr, dA over dr. That is what we have to find out. So we know the value of r, isn't it? How do we find out? So area of the circle, let us start by finding out the area of the circle with the formula pi r square. Yes, my screen is not being shared, is it? 1 minute. Can you hear me? 1 minute, I will see. Where is it? Where is it? This one, right? Yes. How about now? Okay. So find the rate of change of area of a circle with respect to its radius when r is equal to 3 centimeters and r is equal to 4 centimeters. So let us start by taking up the formula for area of the circle. Area of the circle with a, if a represents the area of the circle, I can write that a is equal to pi r square, right? Now what do we have to find out? We have to find out how a changes with respect to r, right? As in dA over dr. So we just have to differentiate this with respect to r. I should be getting my answer. So rate of change of area with respect to radius is given by dA divided by dr. So what is your a? A is pi r square. So d of pi r square with respect to dr, meaning that we have to just differentiate this. So I'll be getting 2 pi r. So at what? When the radius is 3, you just plug in the value of r as 3, you will be having your answer. 2 multiplied by pi multiplied by 3, it is going to be 6 pi centimeter square. Similarly, over here, when it is 4 pi centimeter square, again the same thing, right? What is the only difference? The only difference is you will be multiplying by 4 over here. Again, area of the circle with r. Radius r is given by a is equal to pi r square. Differentiate with respect to r. So dA over dr is going to be equal to pi r square differentiated with respect to r. It is going to be 2 pi r. 2 multiplied by pi multiplied by 4 is going to be 8 pi centimeters squared because we are talking about the area. Yeah. So this is how we solve both of the questions. So A and B, both of them I have solved. Right. I'll be sharing both of them, all of them later on. Right. You can make a note later. Let me go to the second question. The volume of the cube is increasing at the rate of 8 centimeter cube per second. How fast is the surface area increasing when the length is 12 centimeters? So what is given? The volume of the cube is increasing at the rate of, meaning that dV over dt is what is given to you. And we have to find out how is the surface area increasing. ds by dt is what we have to find out, right? So I will start by writing down, let x be the side length of the cube, let v be the volume of the cube, and s be the surface area of the cube, right? Now we know that the volume of the cube is given by what? X raised to the power of 3. Yeah. Now what is dv over, okay, or I can start by taking s also. S is the surface area, 6 multiplied by x square, where x is going to be the one of the side length, right? Now what is given to you? dv over dt is what is given to you. Yeah. Now I will start by writing down what do we have to find out. We have to find out ds over dt, right? Now I will start by taking the formula for volume. Volume is given by x raised to the power of 3. Now I will differentiate this one with respect to t, right? But as you can see, do we have t over here on the right hand side? No, right? So what do we have to do? We have to use the chain rule. Okay, I hope you are getting it. So over here, when I use that, so basically it is something like this, right? So we don't have dt over there. So in order to find out dv over dt, right, what I will do, I will find out dv over dx and I will multiply dx over dt such that these both will be getting cancelled out, right? So that is what I will be doing. So when I differentiate v with respect to t, I will be getting dv over dt. When I differentiate x raised to the power of 3 with respect to t, first I can differentiate x with respect to v with respect to x. I'll be getting 3x raised to the power of 2 multiplied by dx by dt. Okay, I hope you are getting it. Now 3x raised to the power of 2 multiplied by dx. So what is going to be this particular value? This is going to be equal to 8 over here. It is already given to us here, dv by dt, right? Now take this particular value dx over dt. What is dx over dt? This particular value, if I transfer 8 to the other side, I'll be getting 8 divided by 3x raised to the power of 2, right? Now I can take this as equation number 1 and I can put a box around it. Now what am I looking for? I'm looking for ds over dt. So I will start by taking s is equal to 6 raised to the power of 2. Now I will differentiate again with respect to t. So first I should be differentiating 6x raised to the power of 2 multiplied by dx by dt. So here I'll be getting 12x multiplied by dx by dt. Do we know what is dx by dt? Yes, from here we know what is dx by dt. Plug in the same value, you will be having the answer, right? So it is going to be ds by dt. It is going to be equal to 12x multiplied by 8 divided by 3x raised to the power of 2. One of the x and one of the x will be getting cancelled out. 3 one time and 12 is going to be 4 times. 4 multiplied by 8 is going to be equal to 32. 32 divided by x, right? So what is the value of x? When the length of edge is 12 centimeters. So you plug in the value of x as 12, simplify, you should be getting your answer, right? So it is going to be 8 over 3. Since it is surface area, it is going to be centimeters square per second. Okay, so this is going to be for surface, this is for the time, centimeters squared, and for time it is seconds. Okay, let me go to the next question. The third one. The radius of the circle is increasing uniformly at the rate of 3 centimeter per second. Radius is increasing. So what is given? dr by dt is given to you. Find the rate at which the area of the circle is increasing, as in dA divided by dt. dA over dt is what you have to find out, right? So area of circle A with radius r is given by A is equal to pi r square. Now, in order to find out what is given to you, dr by dt, this is what is given to you, right? Now I will differentiate or find out the rate of change of area with respect to time, not with respect to radius, with respect to time. So I will be getting dA over dt is 2 pi r multiplied by dr over dt. dr over dt is already given to you, right? So you plug in the value over here, you should be getting your answer, and r can be taken as 10, right? So you'll be getting 2 multiplied by pi multiplied by r, which is 10, and dr over dt is 3, right? So the final answer is going to be 65 centimeters squared, again because we are talking about the area and per. Are you getting an idea now? Yeah, let me take up the next question. And here, an edge of a variable cube is increasing at the rate of 3 centimeter per second. The edge of the cube is increasing. So if you take up x as the edge, it is going to be dx over dt, right? How fast is the volume of the cube increasing when the edge is 10 centimeters long? So what do we have to find out? We have to find out dv over dt when the edge is 10 centimeters, right? Again, I will start by writing down what is given to us, right? dx over dt, this is what is given to us. How the side is changing, right? What is the formula that we know for volume? Volume is given by x raised to the power of 3 if I consider x to be the side length of the cube. Now, dv over dt, when I differentiate with respect to t, I will be getting dv over dt. Can I differentiate x raised to the power of 3 with respect to t? No, I cannot directly. So I will differentiate x first. I will be getting 3x raised to the power of 2. Multiply that with dx over dt. Right now, from here, I already know the value of dx over dt. That one I can plug in over here, and the value of x can be taken as 10. And the final answer is going to be 3 multiplied by x square, 10 multiplied by 10 multiplied by 3. 3 multiplied by 3 is 9. 9 multiplied by 100. It is going to be 900 centimeter square, right? So sorry, this should be centimeter cube. I want you to change this. Okay. So this is not square, this is cube because we are talking about the area. Sorry, volume, right? So this is 900 centimeter cube per second. That is the difference. So if it is area, it would be square. If it is just the length, it would be just centimeter or just meter or just feet, whatever is given to you in the question. Let me take up few more questions and I'll be giving you few questions to solve later on. Fifth question is, a stone is dropped into a quiet lake and waves move in circles at a speed of 5 centimeter per second. At the instance when the radius of the circular wave is 8 centimeters, how fast the enclosed area is increasing? Again, so what is given to you? How fast the radius is increasing. That is what is given to you, right? So area of the circle A with the radius R is given by pi r square. This is the formula for area. What is given to you? A stone is dropped in a quiet lake and waves move in a circle at the speed of. So basically the radius, how it moves, right? Waves doesn't, the radius is moving. So dr over dt is 5 centimeter per second. What is asked? At the instance when the radius of the circular wave is 8 centimeters, how fast is the enclosed area increasing? As in dA over dt is what we have to find out, right? So again, you start by differentiating A, right? With respect to t, I should be getting my answer. So dA over dt is going to be equal to 2 multiplied by pi multiplied by r multiplied by dr over dt. You know the value of dr over dt. Plug in that value and take the value of r as 8. You will be having your answer. So it is going to be 2 multiplied by pi multiplied by 8 multiplied by 5. So it is going to be 80 pi centimeters squared per. Okay. Similar questions will be given. Let me go to the next one. There are about, I guess, 15 questions. The radius of the circle is increasing at the rate of 0.7 centimeters per second. What is the rate of increase in its circumference? Now, the circumference is asked, right? So let me start by finding out or writing down the formula for circumference. Circumference of the circle is given by 2 pi r, right? What is given to us? The radius of the circle is increasing, as in dr over dt is what is given to us. Now let me differentiate c with respect to t. So dc over dt is going to be 2 pi r. When I differentiate r, it will be equal to 1, so it will be 2 pi as it is. Multiply that with dr over dt. dr over dt is already given to you. So 0.7 multiplied by 2 multiplied by 5. So it is going to be 1.4 pi centimeter per second because we are talking about the circumference, right? So it is just circumference for, just centimeters as we are talking about circumference. Okay, we have few more questions and then I'll be giving you the question to solve. A balloon which always remains spherical has a variable radius. Find the rate at which its volume is increasing with the radius when its latter is 10 centimeters. This is the question. Again, a balloon which always remains on a spherical shape, find the rate at which its volume is increasing. Right? This is what you have to find out, right? So let us start by taking up V to be the volume and R to be the radius. So we know that V is equal to 4 pi R raised to the power of 3 divided by 3, or 4 over 3 pi R raised to the power of 3. Both are one and the same. Now what do we have to find out? Rate of change of volume with respect to radius. So dV over dr now, right? So no dr over dt. So we just have to differentiate this. We'll be getting our answer. So when I differentiate this, I'll be getting 3 multiplied by using the power rule, right? So 3 multiplied by 4 pi over 3 multiplied by r raised to the power of 2. 3 and 3 will be getting cancelled out. 4 multiplied by pi multiplied by r square, which is 10. 10 multiplied by 10 is 100. 100 multiplied by 4 pi, it is 400 pi centimeter cube, because we are talking about volume now. How volume is changing with respect to the radius. Here you have to be very careful. What is asked, right? If it was rate of change of volume with respect to time, it would be different. You would require dr by dt in that case. Here, dr by dt is not at all required. The radius of the air bubble is increasing at the rate of half centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeters? Again, we are talking about volume. So you start by taking up the formula for volume. Volume of the sphere is given by 4 pi r cube divided by 3, or 4 over 3 pi r cube, right? What what is given to you? How fast the radius is changing? It is half centimeter square or 0.5 centimeter square. Differentiate v with respect to t. So you will be getting what? 3 multiplied by 4 pi r raised to the power of 2 divided by 3 multiplied by dr over dt. 3 and 3 will be getting cancelled out. So I have not written that down that, right? Now 4 pi r square. What is your r? R is anyway 1. So I can ignore that. 4 pi multiplied by half, right? So it would be 4 multiplied by 5 multiplied by 1 multiplied by 1 multiplied by half. 2 and yes, 4 will be getting cancelled out. So it will be left out with 2 multiplied by pi. And since we are talking about the volume, it is going to be 2 pi centimeter cube per second. Clear? Yeah. And here it is going to be 400 pi centimeter per centimeter cube per centimeter. Okay, I want you to mention this over here. It is per centimeter itself. Okay. How? No, no. So it is just the ratio. How it will change, right? So what does this mean? For every 1 centimeter change in the radius, 400 pi centimeter cube will be the change in the volume. That is what it means, right? We are not finding out if that. Okay, you are talking about physics, right? There we do it. Yes, dimensional formula, right? The ratio dimensional formula is going to be, yeah, whatever you told is true, centimeter square aa jata hai. But we are not finding out that, right? We are not finding out the ratio. We are finding out how far it changes. That is what it means. Okay. I think after this, yes. Now I have a few questions. I think I will. My screen was visible, right? I didn't ask him.